Hello, welcome back to another riveting. We'll go with that. Did I say riveting? That's already been one of the adjectives, right? Riveting. Yeah, I think I used that one already. Okay, take two. Welcome back to another mind-bending episode. Have I used that one also? We're gonna go with it. Mind-bending episode of How to Do Stuff with Mr. Stevenson. This is episode 45. We're still on proportions, and we're talking about the constant of proportionality. What does that actually mean? Well, remember what we talked about last time. Proportions would be, let me switch to my pen tool. A proportion, of course, would be if we would say 5 to 4 is equivalent to 15 to 12. We would say those two ratios are equivalent. If we multiply the 5 times 3, we get 15. If we multiply the 4 times 3, we get 12, right? So those are called proportional. The constant of proportionality, basically, if you kind of go back to the olden days of elementary school, the days of yore, we'll say, you guys learned fact families, right? So you learned that 4 times 2 equals 8. I think maybe you did them in these triangles. You went 4 to 8. And 2 times 4 is 8, and 8 divided by 4 is 2, and 8 divided by 2 is 4, right? You did that kind of thing. Fact families. So if you look at this equation right here, the equation y equals k times x. This would be like the y. If we write this, if we change it around. Here, let's change it around. Let's go 8 equals 4 times 2. Okay? Remember, y equals kx. Kx means k times x. There's a multiplication symbol not showing when you see numbers next to each other. K and x both represent numbers. Okay, so technically speaking, the 4 would be the constant of proportionality. If that's true, then so is k. If this is y equals k times x, then we can also write it backwards, where k, the 4, equals y is the 8 divided by x, which is 2. See? So we can write them in reverse. So 8 equals 4 times 2 is the same thing as 4 equals 8 divided by 2. So that's why I was saying if this equation is true, then so is this one. Does that make sense there? If not, leave a comment, get a hold of me somehow, and I would love to help you. Okay, so we're talking the constant of proportionality. So how does that? So you can use the constant of proportionality, or you can go find it in tables and in graphs and in a description like you're seeing over here. Okay. So first, let's start with tables. Okay. Let's say a 1, 4, 2, 8, 3, 12. And let's just give a bigger one, like say 9, 36. So you can find the constant of proportionality. So y is equal to that constant times x. How do we get, if y is 4, x times what? So that's basically x times what? This constant equals 4. The k, the constant that you're multiplying, is y divided by x. Well, y divided by x is 4, correct? Is it true for all of these? 8 divided by 2 is 4. 12 divided by 3 is 4. 36 divided by 9 is 4. So this right here is true. We found the constant of proportionality. In this case, the constant, k stands for constant in this case, and the constant of proportionality is 4. Pretty simple, really. You can do the same thing on a graph. I'm going to use different numbers this time instead of using these exact same numbers. It would be convenient because 1 on the x and 4 on the y, boom. But if you look at this, I already have a line built here. So what we're going to do is we're going to place those points on the line 5.2, 10.4, and 15.6. Those are the points that you see. And if I write those down, so remember, going back to that last episode, this is our x-axis, and this is the y-axis, and we do the x first. We read the x-axis first, followed by the y-axis. Okay? So we always go here. So you go 5 on the x, 2 on the y. I go 10 on the x, 4 on the y, and then I go 15 on the x, 6 on the y. So if I had to write down those, it would be the ratio is 5:2. Okay, that first point is 5:2. The second point, 10.4, and the last point is 15.6. So what's happening? So if I were to set this up in a table of numbers, which maybe helps, and this is the x, and this is the y, it would go 5.2, 10.4, and 15.6. Now, what am I multiplying by to make this 5 into a 2? Okay, so y is equal to the constant times 5, or the constant is y divided by x. What's y divided by x? What's 2 divided by 5? If you've learned anything from the previous lessons, 2 divided by 5 is... So then the constant of proportionality here would be 2/5, right? Only if these are proportional. Does 4 divided by 10 right here? Does 4 divided by 10 equal 2/5? Yes. 4 divided by 10 equals 2/5, because we can simplify it. 6 divided by 15, if we divide those both by 3, I get 2/5, right? So my constant of proportionality is 2/5. That's how you're going to do it in a graph. The last one is in a description. Like if I just gave you a problem, like Darius is mixing cement for a new in-ground basketball hoop. He uses a mixture of 80 pounds of concrete with 6 pints of water. So can we find the constant of proportionality from that? We're going to say the 6 pints is y, and the 80 pounds is x. We're going to do it that way. And so you're going to go up here and you're going to say, okay, I'm going to use the formula. The constant is y 6 divided by 80. And then if you take a calculator and you divide that out, you'd get 0.075. So that's it. That's how you find the constant of proportionality. And then if you were to write an equation out of that, here's how you would do it. Okay, pretty simple. You want to use this as the equation. Y is 6, right? So y equals whatever the constant is. What was the constant again? 0.075. I should probably write this in a different color. Times x. That's your equation right there. Let's put a circle around that and call it good. That's your equation. Y equals 0.075 times x. Pooh, there's a lot of information right there on constant of proportionality. Of course, if you have questions, you should by now know where to find me. Either right here on this channel in the comment section, or for those of you that know me, I'm really easy to find. Toodaloo.